Welcome again to Wickerson Studios. My name is Michael Wickerson, and I am hard into C# nodes in Grasshopper for RHINO3D. If you have an interest in moving into scripting and definitely want to know more about the .NET framework, and you're a very visual person and you're good at node scripting, and you want to make that jump, or you think there's a hybrid method for you, this is it, period. And I don't know how long I'll stay here, but it shows you the power of being insane, because I think I actually have gone there. This is the form, as you can see, generated pretty simply from curve, but I want to show you the complexities and the so many permutations that would have led up to this, and why this exists the way it is. You'll see. I have started. Basically, let's pan out. Let's pan out. All right. So what I've done. And I haven't even brought this to another iteration to finish it. I'm only in a playful stage now. What I did, and everybody knows if you watched the last videos, is I found some nodes from ISIS components online. And I did a few little test scripts like that with that. Then I found the Rhino geometry, of which you've been doing online, and did some more as they started to grow. And I did the Warsaw University technology nodes, and I wanted to get those down under my belt to know that they're all available to me. And then I found my favorites. And I went in here and I said, listen, here are my favorites, and I'll just stretch this out. My favorites are pretty much here as it comes to, and I put them all up into my Grasshopper bar because I'm a little insane in that way as well, and it's stretching off the other page. Maybe I need to pull it down at this point. Over here, I have the ability to go in and grab all of those nodes. If I grab the W, you see the Warsaw C nodes, but I've grabbed my favorites here. I'm just going to show you that priming prime factors of numbers. It's usually number processing for me. I think geometry is based in number. I think there's beauty in that, and you have to find out exactly what you want. I then went on to do things related to lines, and then I did a bunch related to loops and curves and series and what I can process data, and that's kind of how I started. And I said, okay, those are kind of important to me. So what I was going to do is set up a template, and I'm just going to jump into here for a second. Just get rid of this turntable for a minute. Maybe shrink this one down because that's the object I've actually made, which I kind of like. It's a pretty cool structure. It's not too hard. It's basically an orientation tool of a curve that's been made into a surface, lofted. And a lot of people will look at me and say, well, why did you just draw out a curve, make the curve you want, and then put it into a grid of points? Well, I wanted to do that, but I thought it would be best to do that through C. So what I did was I set up a scenario here. That this would be my first generation play. And I'll try and make sense of this. This is my exercise number 9. You'll see a repetitive nature of these systems in here. What are they? These two are a little different, I think. But basically, I went in and I said, okay, let's generate some points. And that's exactly what I did. And this is my test script. This is how I'm going to begin everything. And what I did was say, okay, let's get some inputs. And you can use the technique of just setting 1 point anywhere on your Rhino. So this whole script is based on 4 points. Which is a nice way to start. Then I wanted to construct data. So I constructed trees of numbers from dealing with a little bit of, I thought I'd use some gene pool and I'd use some number sliders to generate numbers. I'd have some that are coming right out of the nodes. You'll see there's nothing on the left, so it just generates things. And then I get point coordinates. I have a transform matrix I can use and then orient those points. And then constantly, I wanted to be able to check the iterations, do the for each loops, check it for series, check it for ranges, check it for for each again, random generation, start some values and number sorting. And so I just did that. And then once I am playful in there, because I'm going left to right, I decided, okay, well, let's do some things with the factors. Let's find a sum of of numbers in tree, find a sum of all those numbers. Let's create the points again. Let's find the distance in there and then generate the length. These actually do the same thing. Pretty much, except that one generates a vector as well. And then throw it through that same kind of iterative questioning of what you have. Then I thought, well, let's process some vectors because it's got a great node for processing tons of information about a vector. If any vectors were produced here, which looks like there would be on this node, I would then want to go in here and hard code in to the script. I'd want to go in and I'd want to change. I want to delete this hard-coded one right here with a comment. Vector v0 and just list it as an input out here on this side. So I'd add v0. Now I can play with vectors and then throw it through that crazy iterative process, which I'm going to use this as a template of really kind of jazzing things up in a way that Grasshopper uses Anonymy, or I think, what's the other one called? I can't remember. It's Hoop Snake. But why not have all the nodes that do that, and you can play with them, get into the script, and change them. Then I want to look at polylines and NURBS curves and to decide if it needed any manipulation, which is kind of hard to do because you're not dealing with numbers anymore. You're now getting into geometries, which it still can do, but it starts to get really complex real quick and slows down your program, even though things in C run very fast. Then I said, okay, let's do some things to those curves. Let's maybe do a process, and let's take it to surface evaluation. So that's the template. That's the playing field. That is the erector set. That is the Lego set that I want to distribute to people and then show you the infinite possibilities of Wickerson Studios. Because these scripts are very basic. I don't know if anybody has intellectual property, the simplicity of some of these. I mean, like, they're really ridiculously simple. So let's go in here and just find the sum and create a double X sum, and for each value in the branch of X branch, add them up. So not too hard to do that. But let's see what happens when you get in here on the first generation playful experiment. Well, first of all, I wanted to start here and I want to feed these with some inputs. And I thought, well, let's feed this one with a gene pool, which I love. Let's feed this one with points. Merge them all in, and whenever we need points, let's bring them in. And then this one, I said, let's have a gene pool, but let's take a list item of it. Let's give it a little bit of motion, and let's call it a transform. So that gave me data. That gave me things. And constantly, I was up here saying, well, let's go in there and find what that data is. So at any point, you can pull these out and see what you're dealing with, what kind of tree information, what is going on within the param. So for anybody that looks at the param viewer or the panel tool and says this is really where it's at, that's what I'm doing. And of course, I do have list items that I'm kind of hard coding and picking things as well. But that's exactly what this is doing. Let me try and click out of here. Then I took the gene pool to do that. I took these merged points to do this, and I took them to feed into here. I fed a transform in, and I used the points there, getting data different on every one. Obviously, I wanted to start pulling things through and doing the next series, which was like feed it first time into this iterative process. I need iterations. Well, this number data was going to give me that. I did want to grab a list item and hard code that at 3, and that said, okay, anything below 3, then you want to keep that as data coming out. So you can check your data and see what happened. Your data gets pretty lazy. I actually don't like that data. I'm looking for the most interesting data, and I liked this data, which seemed to be pretty cool and informative as to what it did, but I stopped short of using it. So I fed it into all these things: series, ranges, for each loops, random number generation, array start to end with values, number sorting, random class. And the one I went with was this random class. I said, this is the one I want. And actually, nope, the one I wanted was the random number generator. So it wasn't the list points. But I thought it was interesting at this point to say, well, what exactly is happening there? What we'll have to do is grab this. And I see what's happened again, which happens all the time. Just give me 1 second. Let's get back here to the toolbar because I've lost it. Oh, what a pain in the butt. Hang on. Let's do my show my toolbar. Hey. Just give me a second. Show toolbar. What are you doing? Oh, you're nasty. What a pain in the butt. This happens. Let me go in here and just extend this. Get my ugly face out of here. I'm not sure where I just shoved it, but I shoved it somewhere. Delete this. Let's leave this and go back into something wireframe so I can see it. I thought I had this on. Show toolbar. Yeah, let me go down here and jump into all my standard tools, which are a lot more helpful. And I can go to my standard toolbar. Oh, maybe it was always there, visibility. Let's just take it off and get rid of it. Well, how many bakes do I have here? Oh, okay. Sorry, I'm getting a little slow. There are my 4 points that were inspiring the whole thing. Let's slam this off to the side. Let's go back into Grasshopper and see what we actually have here. There it is. Let's make this a little smaller, and we can start to process what's happening. So this was a curve that I generated, and I really like these little curves, and they had different periodic values. I set it to -1 indices to call out the last one, which was a double. So I'll do a little fancy footwork, and I was like, I like these pipes. This is going to be the basis of what geometry I drew out of that. Now, that's a long way to go to get 3 curves. You know, most people say, well, that's crazy, but you know what? That's how crazy the mind gets, as into having control over this. Now, I did like those numbers that came out, and I thought these were the interesting ones that actually formed. You can see there's similarities, there's changes between them. But this data, after all of that, which actually isn't that much, It's just this node processed through this one, which was a list item going through this node, which was construct tree and numbers, came from a gene tool. So it's actually not that much information, but you can see how this trees out horizontally to become more and more complex. So what did I do? Let me have a look. It might help if I just delete this because it's starting to really bother me. I thought for sure that's where I went and said that was the first iteration to get to these pipes. And then I was like, instead of complicating this, let's go to a second generation. So let's go back into that, put that back on, and say, here's our next generation. Let's do the same thing. Follow this through from the points to these shapes. The gene pools was one in use. You got to follow these paths, and I like this way of making because I can keep this system up. I can add to it a little bit. I can double these kind of iterative panels and slide it along. And these are the files that I'm going to start sharing on GitHub and the C clusters and show you what it's capable of. But since I went from that system of points, that's really what that first couple of nodes generated. I was like, well, let's take it and let's get some point coordinates and let's run it through this. Finding prime factors, finding the sum of everything. But the prime numbers definitely, the factors coming out of there are pretty interesting. I like them. And I like the true-false Boolean you get out of it. So these are all things that you can actually use in C to generate, further call patterns and things like that. This definitely is the points I liked, and I like this one as well, which is very similar. It gives me a distance. You can see that those distances could come into play. The numbers are in an average of where I like. And so we grab a list item of all of these vectors that were generated. You're not going to see the vectors unless you grab a display tool. So you really have to have some experience with this. Let's just grab the vectors and see what they're looking at. Vectors and give it an anchor point. It should be all right, but I don't have it amplified, so it's probably pretty infinitesimally small. Well, where'd it go? Maybe it's big. What the heck? Vectors. Oh, I didn't get my anchor point. Yeah, there we go. That's what you've got. You get this jive of information. That's what I really want. And I'm taking that list item and taking this list item. And I'm actually treating as vectors and saying, okay, let's process it. And that's where I went in and I took out this script. I commented out vector 0 to be hard-coded in here and added it to the vectors coming in and I actually plugged in one at a time. So if I plug in one single vector, which is basically all I've generated, all that script was come down to this vector, which is ridiculous because, what's it going to end up making? And then I get my values into there. What's nice is I've generated a few different things to get here. What I'm also pulling from is the data here. Let's get this out of the way. I pulled all of these vectors out of here. So these are the vectors that play into this vector. And you can get a little lost in the script. I'll probably share it online because it's so complex just to be playful. And there I was grabbing all my data. I plugged it into a merge tool, and that's what processes through that nice C script, which generates everything from dot product and cross vector and all that. Then I wanted to get my point coordinates at my scale, which was basically something I didn't go farther in using, but I ended up using my 0.0, my 0.1, and my add vector for my XYZ with this spacing to make this grid of points. And this grid of points is right there. So that's where I want to put everything. So I'm keeping that data. I'm saying, okay, I'll use that later. I'll use this information, which was a relay of points, this series of 27 points, this series of 27 points. And I thought, well, let's take it to creating a polyline from points. Not too interesting, but it's a lot more interesting as a NURB surface. And I'm seeing something here. So I'm taking that NURB surface, I'm at a curve, and I'm skipping this iterative process now. I had this in here, and I was going to process it in between. But since I'm into geometry, I was like, what would I do with those awesome curves that I've generated from those vectors? And so what I did was I took it to a loft. I saw there was one here that I really liked. You could go in and evaluate. I thought I might use the evaluate point at different stereos there and have that as where I want to orient it. But I didn't end up using that evaluate point because I'm moving towards an orientation onto that grid system. And now I have a distance of what I can actually balloon this out and bring it in. And I like that. It's pretty cool, the shape that I start forming. And how is that being formed? I thought, well, let's send it into the breps. Let's send that flattened surface into the breps, and let's take out some information from it. And what I found was I could just use this node with a little bit of fudging, and it falters at one point in it. There's no instance in it. It doesn't mean the script doesn't run, but what I'm able to do is step through that as an indice item, and I thought I had it listed here. At any point, I only had this count at this point of 9 lists, so I thought, well, let's just take it through here and take a look at the 8 count. and see what actually happens as I grab the different curves that are coming out of it. And it's pretty complex. You see I'm kind of in my head right now. And there you go. You're grabbing these incredible curves that are lofted between the outlines of those breps. Some are very minimal, some are very small, but these are basically from chasing this algorithm. If I pared it down to what it was now, I'd be very excited to see what would happen. I've lost my loft. And what I do then is I just recalculate the centroid from another C script. I am going to orient these geometries onto that grid geometry of points using that centroid, and that's how I end up with shebang. And I just love it. I mean, it's a long way around something intuitively drawing and making like an artist, but I don't care. I actually really find that script exciting. I think 90% of it, 99, 95% of it is C scripts. Trying to have an understanding of that, and at any point, going in and saying, okay, what exactly is in use here? It's a pretty complex one that I ended up not even using, and it uses a lot of variables, so it tells me it's probably RHINO3D's script. But it's one that's, it's open source. You can go grab it. It gives you a bunch of values of a brep. I am following Jose Luis's guide to take surfaces over to breps so you can do things with them in the coding and scripting. But in the end, it's actually cool because I actually have an unrolled surface here showing what could happen if you unrolled that surface out and how you'd have to make it. There's a lot of information on C, a lot to pull from, and there is almost my final iteration. First generation playful experimental. Probably don't even need that. I probably could go right now from this system, because this is just copying that first top one. I could delete all these because they're not in use and say, hey, listen, here's my second iteration of a playful script. Let's group it together. Let's take it over, and I know it got a little chaotic there in the middle. I almost lost myself in my own mind. There it is as a form to end. Take everything else on it. Take that over to preview off, and then I thought I had a form here that I liked. I'm just going to take that preview on, and there's my final geometry. Got a little kid coming in from the snow. There we go. And pretty interesting. You can grab the blue. You have total control over this. I like the fact that I can change it with one little plug to different types of geometries, different curves coming out of the similar geometry on the same scale. And some of them are hard to see what's happening. Every odd number is actually, you could do another filter on that. You're getting another strange shape. I did like that expanse of distance. That could be interesting to see how that changes as I play through rolling that. A lot of data left hanging in this system of playing this way, but it's a way to think of scripting and finding geometries. Sorry about my microphone. It's a way to find some geometries through a very playful structure. And I'm going to constantly use this for a while. I'm going to go in and do the next one. This was 09, first generation. That was, we'll actually call this one, in case people are interested in getting a copy of this, let's just call this template. Yeah, let's do that right. Let's just do template. Oops, sorry, my fingers are kind of clumsy. And that's the template to start with. Then you go in there, you start adding what you know how to do in Grasshopper. It's kind of like working nodes off the shelf, except there's an awful lot of awesome nodes up here that I've already plugged in. I will share these as they become more and more frequent and popular, and as I start to customize them and change them. All these are online. I leave it up to you to track it down and find out where they are if you want to use them, and start building your own geometries. And as you move from 6 or 12 nodes in a system, what I can do here is put this on and say, listen, let's just take a look at these. And there you go. You should have another geometry in here. If I set this one on, you'll see I had one that I shared earlier on a video preview on. Actually, I think it's enabled. You'll see I had a geometry here that I had total control over, beginning simply. Always start with a half dozen. And as we go in here and grab maybe this surface or the other surface for that matter, or both surfaces, that's it within my whole system. I don't want that. Let's just grab these two, and you can see what I can do through a simple 0 pi to 2 pi. I can have some really nice control over a little globulate or nobulate, which I showed before. But that's nothing compared to, you can take that object, no problem, and use it on the same orientation to a grid of points, and you'd end up with something as complex as this. But I like the way I'm actually thinking of generating stuff like this. So let's close this out, actually maybe with a bake. We'll group them all together. We'll leave Grasshopper like that. We'll disappear. We'll extend this one over. maybe throw that into the same rendering that was there. Actually, I kind of like that rendering. Just give me 1 second. We'll go over here. We'll pop it into technical, pen and ink, and I love it because I wouldn't be sketching this way. I wouldn't be drawing this way. I like the repetitive nature of it. I like the forms that are being generated. There's a bunch of architects online that are really like their work in pattern making. I do like the artistic drawing that's happening here. This chaos and creativity stemming from numbers and thinking of the power of mathematics and computational arts is what it's all about. Not sure where this is going to go. I don't know if I'm keeping it simple. It's incredibly complex. If you break it down, it's not actually that complex at any stage, but I do find it very interesting, and I hope you do too. Where's my little grasshopper? I'll try and frame this up as to what it is. It's pretty nightmarish. There it is. And you've got it something worth getting lost in. Hopefully I can kind of spoon feed this to people and take sections out and really find this template that might actually be handy. But I'm doing exactly what I said I was going to do. I'm finding the nodes, especially this middle node cluster of what are the essential C scripts for making things iterative in number and changing things. None of these are very difficult to figure out and write, but they do have some really powerful implications of what's actually happening in processing your data. So that's it. In a nutshell, Wickerson Studios. My name is Michael Wickerson. I hope you enjoyed it. Thank you for watching.